Hello everyone, this is CENG 423 Project 1. Our project is about glass fiber reinforced concrete, abbreviated as GRC in our presentation. Our group members are myself, Noor Akrouche, Layla Amin, Nurhan Helmi, Sharifa Ismail, Aya Abdel Fattah, and Abdelrahman Mahmoud. First, we will start with the definition of GRC. GRC is considered to be a type of fiber reinforced concrete that is extensively used in architectural purposes as well as some structural ones. As the name implies, GRC is a mixture of high-strength glass fiber and highly sophisticated cement matrix. GRC is considered to be a sort of hybrid combination with best physical and chemical features. It is generally compared to precast concrete panels, taking into consideration that GRC is significantly lighter than regular concrete. The first time GRC was used in history was in 1940s. It was not still developed as we can see it now, and the British solved some problems that the GRC had in early 40s. Starting 1960s, it started to gain its popularity, and in the 70s it started to be used in the United States. As for Egypt, it was introduced in the 1990s. The advantages of GRC is that it is designed to be a homogeneous material. It is very safe. It is chemically resistant, which means it does not corrode. It is made of inorganic materials. However, because it's very resistant to fire, it will not burn, which makes it environmentally friendly. And the most important feature of GRC is that it creates dramatic weight reduction in the structure. Concrete. Other advantages include the reduction of work time and the reduction of labor that is used by less than 50% than regular concrete. Also, its maintenance is simple and it is very effective in building rehabilitation. The technical specifications are shown in the following table. This table just proves that it has a very high strength that is comparable to the regular concrete with lower density than concrete and lower weight. The manufacturing process of GRC involves the factory receiving a design from the client, which is customized for the client's request. Molds of GRC are made of steel, rubber or plastic or other types. The GRC is molded, it is poured, different mixing techniques are used, and finishing is done through different coats. And the detailed manufacturing process for different types of GRC will be later discussed in the slides. The installation method is mechanical in most cases. It involves a chemical bond between the different components of the GRC. The process depends on a material being attached to GRC. The stainless steel parts are integrated together and fixed into sockets that are drilled into the wall. Seating with an angle fixed by nails on the backside of the GRC plates are attached into grooves that are later attached into the facade of the building or the different structure that the GRC is applied to. The resources needed for the manufacturing of the GRC include equipment, labor, and transportation. The equipment are usually equipment divided into the pumping and the spraying as well as the mixing. This slide shows different styles of pumping as well as different types of spraying. The spraying is done by different coats such as epoxy and acrylic or other materials. As for the mixing and the batching, the mixes in the materials include the cement, the fine aggregates, the water admixtures, the polymers and pigments. The mixing is usually done by a high shear mixing machine that combines all these materials into a homogeneous GRC mixture. Other equipment include an electric glass fiber chopper, which cuts down glass fiber into smaller pieces and stores it and feeds it into a spray gun that mixes it with cement slurry in order to create a homogeneous mixture. There's also a water and polymer admixture dispenser, which mixes the admixtures and forms the materials into coatings that will be covering the GRC. As for fiber feeders, these include concentric GRC spray guns, which also chop the fiber threads and simultaneously mixes it with the GRC while the material is being sprayed. And finally, there's a molding equipment which creates different types of molds into different shapes, which makes use of the advantage of GRC of being easily shaped. As for the labor, it usually requires a range of low-skilled to high-skilled labor depending on the type of applying of GRC. GRC, as we will discuss further, is either done by hand spray or spraying premix or vibration cast, and the level of complexity increases with the increase of the complexity of the technology being used. The vibration cast premix is the most complex and will require more skilled labor. As for the transportation of GRC, it's usually transported via a crane from the factory to a truck that transports it then to the site. The trucks usually have an inverted T hanger, which consists of hooks that suspend the GRC panels. It must not be twisted or overstressed while being transported. And GRC is lightweighted and hollow, which is not hard to transport. However, exercising care is very important as not to damage the GRC as it's being transported. Quality control for GRC includes checking the thickness and the fluidity and the glass fiber content. The equipment needed for such measures is drying test samples, curing tanks for test samples, and lab balances for weighing GRC, and vernier calipers for thickness measurement. The maintenance of GRC includes adding chemicals to restore it, to fill gaps when gaps are created in GRC panels, and the colors may be changed as they wear out with time. There are 3 different types of GRC, although 2 of them are the generally used ones: the premix GRC and the spray GRC. The spray is divided into 2, automatic and direct. The difference between the premix and the spray is that the premix has fibers that are randomly oriented in 3 dimensions, and it is difficult to achieve high fiber concentrations, therefore the strength levels are usually low. As for the spray GRC, it has 2D fibers and higher fiber content, so it is mostly very strong GRC. The direct spray mixing GRC, which is the one that is mostly used in Egypt, is applied from a spray head that combines a cement sand slurry as well as glass fiber chopper that creates a homogeneous material with large panels being created. The different types of GRC can be compared through different criteria. First, the fiber content, and as we can see in this figure, the sprayed GRC has the highest fiber content, which means that we can achieve the highest strength levels through the higher level of fiber. The next criteria of comparison is the physical properties. As it can be seen in this table, there are different strengths criteria: the bending, the tension, and the shear, and the premix is compared to the spray, and as seen, the different numbers compared are higher in all types of strengths for the spray GRC as compared to the premix GRC. These tables compare the mixed design of the GRC, the premix, and the spray with different grades being applied. These have criteria such as the aggregate cement ratio, the water cement ratio, glass fiber content, and polymer solid content. The next criteria of comparison of the types of GRC is the manufacturing process. First, we will start with spray GRC. The manufacturing process usually starts with weighing and batching, and this is done both for dry ingredients and liquid ingredients. Next comes the mixing, which is done for the cement slurry using a high shear mixture, and the slump test is later performed to ensure that the slurry has proper consistency. Next comes the spraying, which is the most integral part of the manufacturing process, and this is done by simultaneous deposition of cement slurry and chopped glass fiber. Different tests need to be done to ensure that the glass fiber is being correctly mixed with the cement slurry. Then a very thin coat of slurry without fiber may be sprayed. Later the GRC is sprayed into a coat. The GRC material must be sprayed in stages of 3 to 4 millimeters a time until the requested thickness is reached. Each layer must be compacted by a hand roller before spraying, and once the spraying is complete, the thickness has to be checked again by gauges and vernier caliper, as we mentioned before. If the thickness is higher than the requested thickness, this could be passed unless there is a limitation on the weight by the designer. However, if the thickness is less than the requested thickness, then more GRC needs to be sprayed and compacted. The manufacturing process for the premixed GRC starts with weighing and batching, which is exactly the same process as in spray GRC. Next comes the mixing. It's also done by a high shear mixture. However, the mixing in this process is done in 2 stages and at variable speed. The slurry is placed in a second mixture where glass fiber is uniformly blended with the slurry. Glass fibers are either chopped manually or automatically before being applied to the mixture. After mixing comes casting, in which the premixed GRC is pumped into a holding vessel and taken into filling station. Then the material is pumped or poured into a mold, ensuring no air bubbles form, weakening the material. The GRC is then compacted using either internal or external vibration. The compaction method is chosen depending on the selected surface of finishing. There are different types of GRC available in Egypt. They have different textures ranging from smooth to wood grained and different shapes ranging from flat to domed or curved, and we will see different shapes that are applied in different sites in Egypt later in the slide. The different suppliers in Egypt are Deco, Egypt and Group, with the following contact information. El Bannaoun also has the contact information. Fibrix Company, and this is one of the biggest companies that manufacture GRC, and these are located in 10th of Ramadan. Safe Construction Materials, and this is where we got our sample pictures on site, and we would like to thank them for their help. Mina Country in Alexandria, and the ordering process happens through contacting the suppliers directly and asking for implementation of GRC inside. And usually GRC is very custom made, so the client has to specify the use of GRC in their site. As for the prices, the GRC panels are usually priced by square foot or square meter in the case of Egypt. The 2 aspects that affect the pricing of GRC are the material cost and the installation cost. The material cost depends, of course, on the size and the complexity of the panels and the repetition of the skin profile forms. As for the installation, it depends on the panel size, the accessibility to the site, the location, and the types of cranes that will be used. The general international prices range between $30 to $35 per square foot for the materials and $6 to $15 per square foot for the installation. The additional sources for costs include the shipping costs and the equipment costs, which are usually very expensive, adding to the cost of the GRC. If compared to conventional concrete, GRC is much more expensive because it achieves very high strength while being very light in weight and very easily shaped. And it achieves very thin cross sections that the conventional concrete does not achieve. Plus, the technology to create GRC is more advanced and less spread than conventional concrete. Pricing in Egypt ranges between 550 Egyptian pounds to 650 Egyptian pounds per square meter, and prices examples in suppliers. For example, Deco offers a price of 565 Egyptian pounds per square meter. The range is almost similar for Al Bannaoun and Nile Pro. GRC is applied in different applications in the engineering world, and we will see different applications in Egypt as well. These applications include architectural applications, building applications, and engineering applications. The GRC in architecture is used very widely in Egypt as compared to other applications. For example, this picture shows us Al-Muntazah Palace in Alexandria, and GRC is used for cladding and landscaping in this site. Why GRC is used in cladding is because it provides very high performance and very thin and lightweight sections that can be used. GRC is also very good in molding because it's alkali resistant and it can be shaped into very fine details, and it's very easy to handle and direct. We have a picture here that shows Burg Saif in Alexandria with also GRC cladding, and as you can see, it has fine details with decoration. In architecture, also GRC is very suitable for landscaping. It is very aesthetically compatible, and this is also very widely spread in Egypt. For example, you can see here stairs that are done by a safe group, also in GRC landscaping, and this is the Corniche Medina Damyat. As for GRC in buildings, it has gained very much of its popularity due to the need for lighter weight building components. This is a building called Bain al-Qasrain in Alexandria, also implemented by Safe Group and using the GRC produced by their factory for structural elements as well as architectural elements in this building. GRC in buildings is very popular in roofing because it's very light and not brittle, unlike other alternatives such as slate and natural stone or clay products. It's also non-combustible and has very high impact. GRC in buildings also includes working with walls and windows. It is used for external insulation, and it provides a crack-free performance. GRC is also used in renovation because, again, it is very thin and lightweight, and it's easily applied into existing structure without burdening it. GRC is also popular in foundations and floors, and it works as permanent formwork. As for engineering applications, GRC is very popular in bridges. As we can see, this is Kubri 45 in Alexandria, where GRC has been used. As we said, GRC is used in permanent formwork, especially in bridge construction for small spans 1 to 2 meters. It provides extra corrosion protection to steel reinforcement. Also, it's used in utilities and railways, as well as tunnels and parapets for bridges. Finally, GRC in engineering is used in water drainage as it provides thin sections that are easily handled and fastly installed, and they provide dense and smooth surfaces that minimize resistance to water flow. Following are some samples of sites in which GRC is used in Egypt, in addition to the ones that we previously mentioned. This is the gateway at the airport of Al-Maza, and you can see how the columns have detailed decorations that are easily done by the moldings of GRC. This is the GRC installation of the facade of a building of Cairo University. Again, it has very detailed decorations that could have not been done with conventional concrete. This is the GRC installation at the Canadian University of Cairo, and we can see that it has taken a different color than conventional concrete, and this can be easily changed and maintained with time. This is a GRC installation in the facade of the Economical Court in Cairo, and we can see an integration of glass and different components that are easily done with GRC. This is the interior at the Distoria Court Club. This has also structural components that are done with GRC through the roofing and the different doors and windows. This is the GRC installation in the extension of the Qattamiya shooting club in Cairo. This is very detailed decoration at different residential projects in Cairo that are easily achieved by the workable GRC mix, especially through the spray GRC. And finally, these are our references, and we would like to thank again Safe Construction Materials from Safe Group in Alexandria, who helped us see different samples of GRC and get introduced to the different machines to produce the different types of GRC. Thank you.